All right, so today we're going to do a deep dive into something that maybe doesn't sound super exciting at first, but I promise it's really interesting. HTTP caching.
Oh, okay.
Specifically how it plays a role in the way that Google crawls the web.
Okay.
So it turns out Google can only cache a tiny fraction of the pages it crawls. We're talking 0.017%.
Wow. That is tiny.
Yeah, it's really small.
Yeah.
So why is that number so low, and
Right.
what can we learn from it?
Well, I think what's really interesting is that even though caching has the potential to really speed up the web significantly, it's clearly not being used to its full potential.
Yeah.
That tiny percentage just raises all these questions about why that is. Is it, limitations in the technology itself?
Right.
Or are website owners just not implementing caching effectively?
Yeah, that's exactly what I'm hoping we can uncover today. And, for anyone out there listening who runs a website, especially a large one,
Yeah.
understanding HTTP caching can be like a real game changer.
Absolutely. I mean, this isn't just some abstract technical concept. Caching has real-world implications for things like website speed, server costs, and even your environmental footprint, believe it or not.
Okay, so before we go any further, can we just back up a little bit?
Sure.
Break down what HTTP caching actually is.
Yeah.
I know the term gets thrown around a lot, but I think it's worth clarifying for everybody.
Absolutely. So think of it like this. Every time you visit a website, your browser has to download all the files that make up that page.
Right.
The HTML, the images, the CSS, and so on.
Yeah.
But with caching, the browser can actually store a copy of those files locally. So the next time you visit the same page, it can just load those files from its cache instead of having to download them all over again.
So it's basically like having a little library of website files stored right on your computer.
Exactly. And it's not just your browser that can use caching. Search engine crawlers like Googlebot also use caching to make their jobs easier.
Okay, that makes sense. Now, the blog post that we're looking at today focuses on two specific methods for HTTP caching.
Yeah.
ETag/if-none-match.
Right.
And last modified/if modified since. And I have to admit, those terms sound a little intimidating.
Yeah.
Can you kind of demystify those for us?
Of course. So let's start with ETag/if-none-match. So imagine each web page having a unique fingerprint called an ETag. And every time a page is updated, its fingerprint changes.
Right.
So when a browser requests a page,
yeah,
the server sends the page along with its ETag.
Okay, so the browser has the page and its fingerprint. Now, what happens when it wants to visit that page again?
So the browser will send that ETag along with its request, essentially asking, hey, has this fingerprint changed? And if the server sees that the ETag matches the current version of the page, it sends back a special response, 3044, not modified.
So 304, not modified, is that like a secret code for you've already got the latest version, no need to download anything?
You got it. And here's the really crucial part. That 304 not modified response doesn't include the actual content of the page. It's just a signal that the browser can use its cached version.
That's pretty clever. It saves bandwidth for the user and processing power for the server.
Exactly.
Now, what about the other method? Last modified/if modified since. How does that work?
So last modified/if modified since works a little bit differently. It relies on timestamps instead of these fingerprints.
Okay.
So the server tells the browser when the page was last updated.
So the browser keeps track of that timestamp, and then the next time it wants to access that page,
right,
it checks to see if the page has been modified since that timestamp.
Exactly. If it hasn't been modified, the server will send back that same 304 not modified response, and the browser happily uses its cached copy.
Okay, so both methods ultimately achieve the same goal, preventing unnecessary downloads.
Right.
But ETag/if-none-match seems a bit more precise with its unique identifiers. Are there situations where using last modified might be a better choice?
Well, there are some nuances to consider. One thing to keep in mind is that timestamps can be a bit finicky. Imagine a server's clock being slightly off.
Right.
Or a file getting modified without its content actually changing. Yeah. That could lead to some confusion.
So ETags are generally more reliable, but the blog post we're referencing did mention a couple of things that can make using last modified more effective, right?
Right. One important factor is using the correct date format in the last modified header.
Right.
If the format's off, browsers might not understand it properly.
That makes sense. It's all about speaking the same language.
Yeah.
What was the other recommendation?
Using the max age directive in the cache control header.
Okay.
This can make things even more efficient.
Okay, let's unpack max age. What does that actually do?
So think of it as the server telling the browser, hey, this content is good for this many seconds.
Okay.
So instead of having to check the timestamp every single time, the browser can just trust that the content is up to date for a certain period.
So it's like an expiration date for the cached content.
Exactly.
That's pretty cool.
Yeah.
Seems like all these little details can really add up to a much smoother experience for the user.
Absolutely. And a faster website is a happier website, both for the visitors and the website owner.
Speaking of real-world examples, the blog post that we have includes some sample sequences of requests and responses
Yes.
for both of these methods, and I think it would be helpful to actually walk through those.
Yeah, I agree. Seeing it in action can really clarify things.
Yeah.
So let's start with the example for ETag/if none match. What's the first thing you notice in that sequence?
Well, the initial response from the server includes the content of the page along with an ETag. In this case, the ETag is a string of characters, kind of like that unique fingerprint we were talking about.
Right, and then what happens when the crawler requests the page again?
The crawler includes that ETag in the if none match header.
Okay.
It's basically saying, hey, do you recognize this fingerprint? And since the content hasn't been modified, the server responds with, drumroll, please, 304, not modified.
Exactly no content, just that confirmation message. The browser knows it's safe to use its cached version.
Okay, I think I'm getting the hang of this. Let's take a look at the last modified/if modified. This example, what stands out to you in this sequence?
In this case, the server's first response includes a last modified header with a specific date and time. It also includes a cache control header, and this one has a max age value.
So the server is giving the browser a timestamp and telling it this content is good for 94,043 seconds. That's more than a day.
Exactly. So for that whole period, the browser can confidently use its cached version without having to check back with the server.
And just like in the ETag example, the crawler's next request includes the timestamp in the if modified since header.
Yeah.
And of course, the server sees that nothing has changed and sends back another 304, not modified.
It all boils down to efficiency. Both methods are trying to eliminate unnecessary work and speed things up for everyone involved.
It's really fascinating how these technical details translate into a much better user experience. Faster websites make everybody happy. But I imagine there are also some challenges when it comes to implementing HTTP caching. What are some of the things that website owners need to be aware of?
Yeah, I mean, one of the biggest mistakes is caching content that changes frequently.
Yeah.
Imagine caching like a news website's homepage.
Right.
You'd end up serving outdated news to your visitors.
Yeah, that makes sense. So you need to be strategic about what you cache. What types of content are good candidates for caching?
Generally static content like images, CSS files, JavaScript files, even articles that don't get updated very often are all great candidates for caching.
So for those of us who manage our own websites, what are some practical steps that we can take to implement caching? Do we need to be like a coding whiz to figure this out?
Not necessarily. A lot of hosting providers offer caching features built right into their platform. And if you're using a content management system like WordPress,
Yeah.
there are tons of plugins that can handle caching for you.
So there are user-friendly options out there. That's a relief. But what if my hosting provider doesn't offer caching? Or my website is a bit more, shall we say, custom built?
In those cases, you might want to consult with a web developer.
Okay.
They can help you set up the right configurations for your specific site.
Okay.
It might involve tweaking server settings or adding some code to your website's files.
So regardless of your technical skills, there's a way to get caching working for you, and it sounds like it's worth the effort.
Absolutely. Faster loading times can improve your search engine rankings, reduce your server costs, and create a much better experience for your visitors.
Plus, as we mentioned earlier, it can even reduce your website's environmental impact.
That's right.
It's a win-win all around. So as we wrap up this deep dive into HTTP caching, what's the one key takeaway you want our listeners to remember?
I would say this HTTP caching is a powerful tool that can make a real difference for your website. Don't be intimidated by the technical terms.
Right.
With a little research and maybe some help from your hosting provider or a developer, you can unlock the benefits of a faster, more efficient, and more sustainable website.
It's amazing how something as seemingly complex as HTTP caching can ultimately boil down to a pretty simple concept, storing files locally to speed things up.
Right.
And the impact of that simple idea can be huge.
Imagine a world where most websites use caching effectively.
Oh, yeah.
Browsing the web would be a completely different experience.
Faster, smoother, and more enjoyable for everyone.
Exactly. So, if this deep dive has sparked your curiosity, I encourage you to explore the resources available and see how you can implement caching on your own website. You might be surprised at the difference it makes.
And for more deep dives into web development and optimization,
Yes.
be sure to check out modevco.com.
You can also find us on YouTube for even more content, so don't forget to subscribe.
And on that note, we'll wrap up this episode of The Deep Dive. Thanks for joining us on this exploration of HTTP caching. Until next time, stay curious.
Yeah, so we've talked about how caching can really speed things up, but it sounds like there's a right way to do it. What are some common pitfalls that people should watch out for?
Well, one of the biggest mistakes is caching content that changes frequently. Imagine caching a news website's homepage. You would end up serving outdated news to your visitors.
Yeah, exactly. You don't want to do that.
No.
So yeah, you really need to be strategic about what you cache. So what types of content are good candidates for caching?
Good question.
Generally, static content is a good choice. Things like images, CSS files, JavaScript files, even articles that don't get updated very often are all really great for caching.
So for those of us who manage our own websites, what are some practical steps we can take to implement caching? Do I need to be like a coding whiz to figure this out?
No, not necessarily. A lot of hosting providers offer caching features that are built right into their platforms. And if you're using a content management system like WordPress, there are a ton of plugins that can handle caching for you.
So there are user-friendly options out there.
There are, yeah.
That's a relief.
Yeah.
But what if my hosting provider doesn't offer caching, or my website is a bit more, shall we say, custom built?
In those cases, you might want to consult with a web developer. They can help you set up the right configurations for your specific website.
Right.
It might involve tweaking some server settings or adding some code to your website's files, but they can guide you through that process.
So regardless of your technical skills, there's a way to get caching working for you, and it sounds like it's worth the effort.
Absolutely. Faster loading times can improve your search engine rankings, reduce your server costs, and create a much better experience for your visitors.
And as we mentioned before, it can even reduce your website's environmental impact.
Right, exactly. It's kind of a win-win all around.
Yeah, it is. So as we wrap up this deep dive into HTTP caching, what's the one key takeaway you want our listeners to remember?
I'd say this HTTP caching is a powerful tool that can make a real difference for your website. Don't be intimidated by the technical terms. With a little research and maybe some help from your hosting provider or a developer, you can unlock the benefits of a faster, more efficient, and more sustainable website.
It's amazing how something as seemingly complex as HTTP caching can ultimately boil down to a pretty simple concept.
Yeah.
Storing files locally to speed things up.
Exactly.
And the impact of that simple idea can be huge.
Yeah. Imagine a world where most websites use caching effectively. Browsing the web would be a completely different experience.
Faster, smoother, and more enjoyable for everyone.
Exactly. So if this deep dive has sparked your curiosity, I encourage you to explore the resources that are available and see how you can implement caching on your own website. You might be surprised at the difference it makes.
Awesome. Well, that brings us to the end of this deep dive into HTTP caching. Thanks for joining us. We'll see you next time for another deep dive.